So yesterday we talked about quadratic functions and how can we figure out if it's a quadratic function from the equation, from the table of values, or from the graph. Today we're going to look at the key features of a quadratic function, number one. And number two, we're going to look at how do these key features change as we change the parent function of quadratic. So as you know, there's always a base that we have to compare everything to, okay? So if you're looking at a quadratic function, to compare all the other quadratic function to that quadratic function is called the parent function. So that's the parent of all quadratics, okay? And it is y equal x squared, okay? So y equal x squared is the most simple quadratic function and is the base of all other quadratic functions. So everything is translation or transformation of this parent function, okay? All other quadratics are a transformation from this one. Are we okay with this? So this is the base function. Do we understand that? All right. So what did we say the graph of a quadratic function look like yesterday? Parabola. That's right. So a parabola is the shape of a quadratic function. So quadratic relation is modeled by a smooth, symmetrical curve known as a parabola. Okay? So here are the two or the three words that define parabola: smooth, symmetrical, curve. And we said that the parabola opens either up or down. Is this a parabola?
No.
No. This does not. It's actually an inverse quadratic. Okay? So it is not a quadratic. If you see a graph like this and they ask you, is it a parabola, is it a quadratic function? The answer to this is no. Okay? The only quadratic function would be if it's opening up or opening down. Now here are the key features of a parabola. Okay? You're going to need to know these key features or how to find these key features, because we're going to need them to be able to graph our parabolas. So when you're graphing a parabola, that parabola is going to intersect sometimes the x-axis, right? So you see how, can you guys see this? So you see how your graph here, right? This is the parabola. This is your y-axis, and this is your x-axis, yes? Can you guys tell me, where does your graph intersect the x-axis? Or how many times does it intersect the x-axis? Twice, right? So it intersects the x-axis right here, and it intersects the x-axis right here. We call these the zeros of the graph, so they're called the zeros, but they're also called the x-intercept. So sometimes we have two x-intercepts, in which in this case we do have two x-intercepts. Sometimes we only have one x-intercept. So I can give you an example.
I know. No. So they were giving you feedback.
Yeah, I get feedback on everything.
So you see how there's only one x-intercept here. So the graph is intersecting the x-axis once. But I could also have no x-intercept. So if I have something that looks like this, right? You see how the graph is above the x-axis. It's opening up, so there is no x-intercept.
They never left their name.
Does that make sense to you? So the maximum number of x-intercept you can have is 2. The minimum is 0. So 2, 1, or 0. So the x-intercept, this is how we define the x-intercept or how we write it. So if I'm asking you for the x-intercept, you're going to say x-intercept equal, in this case, it's -1, and I'm going to say this is 3. Okay, so you're going to have to name them x-intercept equal -1 and 3. You're going to have to include this. You either write x-intercept or you write x. So you can write x equal -1 and 3.
Awesome. Thank you.
If not today, then tomorrow for sure.
Okay, great.
Now, notation is half the mark. If you don't write x equals 2, then I'll remove half a mark right there. When I ask you for the x-intercept, you're going to have to write x equals 2. So x equals, and you write your x-intercept with and in between them. Is that clear for everyone? Okay. There's another way that we can name the x-intercept. So you can choose to name the x-intercept as points, and then you can name them as, in this case, it's going to be -1, 0, and 3, 0, because this is the point which is -1, 0, and this is the point which is 3, 0. Okay? So you can pick either this notation or this notation. Okay? I don't want both of them. You can pick one or the other, whatever you find easier for you. Are we okay with this?
You say you don't want both.
No, I want one or the other. Where did I get the -1 and 3 from? It happened, like, it's not very clear here, but you see how this right here, this is a -1, and this 1, 2, 3. Okay. That's the x-intercept because this is where the graph is intersecting the x-axis. Are we okay with this? So there's 2 names for it, either the zeros, actually there's more than 2 names, but we say zeros, x-intercept. Another name for it would be solution. When they're asking you to solve, it will be they're asking you for the x-intercept. We'll talk more about this in the next unit, but there's also another name that some books use. It's called roots as well. So these are all the same, mean the same thing. Are we good with that? Have the y-intercept. Okay? So remember I said this is your y-axis and this is your x-axis. How many times does your graph intersect the y-axis? Once. And it's never going to be more than once. Okay, it's always going to be only in one spot. Sometimes you don't see it, okay, but it will cross it, okay? But sometimes, let's say if you have a graph and the graph is way here, right? You don't see that it's crossing the y-axis, okay? But it will. as it goes up, it will cross it, okay? But I won't be asking you questions like this where you don't see the y-intercept and I ask you for it. Okay? So your y-intercept is right here. And if I'm going to state the y-intercept, what do I say? Y equals -4. So this is how I state it. It's y equal -4, right? So this is -1, this is -2, this is -3, this is -4.
We don't have those little squares.
You don't have them because of the photocopying, right? It won't pick them up. And then I had to zoom in to see it. Okay? The other notation, so either or, the second notation that you can use would be the point notation. So you can say y-intercept, and then you can write as a point, and in this case, the point is going to be 0, comma, -4. Because the x value is 0, the y value is -4. So you can pick one or the other. I don't want both notation. Either, whichever easier for you. I find a lot of students mix up between these two, right? And then they don't know where to put the 0. And that's why it's easier to pick the first notation. Okay? So they don't know if they should put the 0 first or they should put the 0 second. So if you don't know and you're not sure, always go with the first notation. XY. That's right. So the y-intercept is when the graph crosses the y-axis. Are we okay with this? So x-intercept is when the graph crosses the x-axis. Y-intercept is when the graph crosses the y-axis. Then we come to the vertex. The vertex is a very, very, very important point on your graph. Okay? The vertex is the point where your graph switch or changes direction. Okay, so in this case, the vertex can be either this point in this case, right? So this is your vertex. This is in the case of opening up, and then in the case of opening down, this is your vertex. Okay, so in this case, your vertex is what? A minimum or a maximum? This is a minimum. And in this case, your vertex is a maximum. You're going to either have a min or a max. You can't have both. Okay? It's going to be either a minimum or a maximum. The vertex, when I ask you for the vertex, I'm looking for a point. When I say a point, I'm looking for x and y values. Okay? So let's look at this. If I'm looking for this vertex, if I'm looking for this vertex right here, my x value is 1, and my y value is -6, right? So when I'm stating my vertex, I have to state it like this. 1, comma, -6. That is my vertex. Okay? So I look at that point where my graph changed directions. So the vertex for this one is also happen to be at 1 and -6. But in this case, it's a max. Yeah.
Negative 6?
Yeah, because that's negative 5. That's negative 6. That's negative 7, negative 8, negative 9, negative 10. Right? Your graph is like this. This is your x. This is your y. Okay? And it happens that the graph is below the x-axis and opening downward.
But it's not like counting up, not down.
Yeah, but when I'm counting with the negative, as I move down, the number gets bigger, right? It's negative 5, negative 6, negative 7. This is what when you're counting.
So the order doesn't change even though it's facing down?
Okay, I just need your attention here for a second. Don't write this. This is your x and y, right? On your x, always, this is your 0. To the right, that's 1, 2, 3, 4, yes? How about to the left? Negative what? 1. Negative 2. Negative 3 as I move to the left, right? Okay, on the y, what's on above here? 2, 3, right? How about below it? Right? In this case, this is what you had. You had this, so this is your vertex and it's opening like this.
I just got confused with the numbers.
Right? Because you don't have the full graph. So this is basically, this graph is right here. Okay? So if you look at your vertex, let me just pull this up a little bit. Right? Don't graph this because I'm going to. So if you look at this, right? My vertex is at 1. The x value is 1. And the y value is negative 6. Right? But in this case, because you don't have the full graph, you couldn't see it, I think. Are we okay with this?
Yeah.
All right.
You're intercepting the y-axis
I don't care about the intercept right now. I'm looking at the vertex. But if you're thinking about the intersection of the y intersection, you're intercepting the y at negative 8.
8.
Yeah. Do you have any x-intercept in this case? No x-intercept, right? Okay, so the vertex is your highest or your lowest point on the graph. Okay? When I'm asking for the vertex, I'm asking for a point, x, y. Are we okay with this so far? Okay. Now, do you guys know what the word axis of symmetry mean?
It's when where it's symmetrical, the
So
middle point.
It's a line, right? Where you can cut the graph and it becomes symmetrical. It's like, when you have a butterfly and you wanna cut the butterfly in half, right? Where it's symmetrical, you actually, I know that's a very bad scenario. I mean, when you're drawing a butterfly and you want it to be symmetrical, let's make it that way. Okay, and draw a line. Now, if you are going to draw an imaginary line that cuts this graph in half, where would you draw it? In the middle, and it passes through the vertex, so
Is that
like
+1?
like this?
Yes.
Yeah?
Plus 1.
Okay. Where you guys said the word. Where does it pass through? It passes through what point? Pass through the vertex. Right? An axis of symmetry always is going to pass through the vertex. But what value of the vertex did it take?
The 1.
The 1, which is the x value of the vertex. Okay? So if you look at this, we said that we're going to draw the axis of symmetry passing through the vertex up, right? It's a little bit moved to the left, but just pretend that it's passing through the vertex. That is going to pass through that 1. Yes? Okay. So whenever I'm writing axis of symmetry, I write it like this. Axis of symmetry, because I don't want to spend half an hour writing axis of symmetry. Okay? Is at x equals to 1. There is no other way that you can note this. So when I'm asking you for the axis of symmetry, you have to write x equals. And it's going to be the x value of the vertex.
Axis symmetry is always 1, right?
No. Whatever the x value of the vertex is, that's your axis of symmetry. So let's say if I have this, right? My vertex here is 3, 4, right? If I'm going to draw an axis of symmetry, it's going to be going down here. It's passing through 3. So my axis of symmetry is x equals 3.
Should we write that?
You don't have to. You want to, go ahead. It's an example. But I'm going to erase this to write whatever I need to write. If you want to write it not in this spot. Okay? So remember that the axis of symmetry takes the x value of the vertex.
So is that one like 1 and negative 6 then?
But what's the x value of the vertex? The vertex is 1 and negative 6, right? The vertex is 1 and negative 6, right?
Yeah.
But the axis of symmetry is x equals 1.
Okay, okay. Oh, yes.
Okay? So it's an imaginary line. Of symmetry. That runs vertically through the vertex. Are we okay with this? Okay. Now, the other part of the vertex, so we talked about the x part of the vertex. The second part of the vertex is called your optimal value. Okay? So the optimal value is either your maximum value or your minimum value that you're going to get to. So we have two scenarios. Remember, if the graph is opening down or if the graph is opening up, we're going to have two different scenarios. So if I'm looking at this graph right here, it's opening up. So is opening up, then it has a minimum or a max? Minimum. So this one is a minimum. What did we say the vertex here was? 1, -6. Okay. So your optimal value in this case is a minimum at y equals -6. The optimal value here is a max or min? Max at y equals, also in this case, it's -6. It happens to be the same, okay? So remember that the optimal value is the y value of the vertex, okay? You can have a min or you can have a max. When I ask you for your optimal value, you're going to say the following. You're going to say it's a min, in this case, at y equal -6. Or, in this case, you're going to say it's a max at y equal -6. So it depends on your case. Okay? So let me give you another example here. What's your optimal value? Is that how you're going to state it for me? Max at, so max at y equals 4. This is what I'll be looking for. When I ask you for your optimal value, you're going to have to state it that way. Okay? What would be your axis of symmetry here? X equals 2. Get used to saying it. Okay? So, the optimal value is max at y equals 4. The axis of symmetry is x equals 2. What would be your vertex? The other way around. 2, 4. Remember alphabetical order, guys. Alphabetical order. X, y. A, B, C, D, E, F, G. X, Y, Z. Right? X, Y. X, Y. Okay? So your X value first, your Y value second. Okay. So we found the vertex. We found the axis of symmetry. We found the maximum value. If you know what your vertex is, you can find the other two. Yes? All right. So let's write this here. I'll get back to this page in 1 second.